right? In this video, we're going to talk about actually using moles in reactions, which is really what stoichiometry is all about. Now that we understand what the mole is, we're going to start using it to figure out how much of a product we can make from a certain amount of reactants. So if we think of a chemical reaction, a balanced equation as being like a recipe, that's very helpful. We can think of this as being 2 moles of hydrogen reacting with 1 mole of oxygen to make 2 moles of water. And so it leads us to a couple of different ratios, relationships between moles of substances in this balanced equation. So for example, I could say that I have 2 moles of hydrogen for every 1 mole of oxygen. Or I could write it as a fraction, 2 moles of hydrogen per 1 mole of oxygen. Or we could flip it the other way around, say 1 mole of oxygen for every 2 moles of hydrogen. We could also look at some different ratios, like we could incorporate the water that's formed, because we can see that for every 2 moles of hydrogen used, so we got this 2 over here, we're producing 2 moles of water, which you could simplify to a 1-to-1 ratio, but either way, it's the same ratio. So what we're saying here is our coefficients give us a ton of different ratios between moles of different substances in the equation. Now, those ratios then allow us to convert between moles of 2 different substances in the balanced equation. All right. So for example, if I'm given a problem like how many moles of oxygen are needed to react with 1.8 moles of hydrogen, well, this is just a conversion between 2 different substances. So I'm going to start with 1.8 moles of hydrogen. Like any other conversion, I'm going to put that over 1, just make it into a fraction. And like any other conversion, I'm trying to get rid of what I already have. So in this case, moles of hydrogen, and I'm trying to find, in this case, moles of oxygen. So I'm used to going from moles to grams, but what I'm saying is, this is where it's a little different, because we now have a balanced equation. So we could go from moles to grams of hydrogen, but that's not what this question is asking. The question is asking if I wanted to use up 1.8 moles of hydrogen, how many moles of oxygen would I need, right? And for that, I just look at the balanced equation. I have a 2 in front of hydrogen, so I can put a 2 down there on the bottom, and I have an implied 1 in front of oxygen, so I put a 1 on top. And just like any other conversion, I can cancel whatever is on the top and the bottom, and as long as where I'm at now, moles of oxygen, is what I'm being asked for, and it is, then it's time to do my math. So I can get out the calculator, or I can, probably this one we might be able to do in our heads, just 1.8 divided by 2 should give us about 0.9 moles of O2, and that's it. Okay. You could also ask the question, how many moles of water are created when we react a different number, 4.9 moles of oxygen. So how would you set this one up? What would you start with? Probably start with the number given, right? 4.9 moles of oxygen. And in this case, it's asking us to go to moles of water. So moles of oxygen, 2 moles of water. And again, I'm going to the balanced equation. I can see 1 mole of oxygen, 2 moles of water, and I'm going to put those in as my mole to mole conversion. All right, so 4.9 times 2, that should give us 9.8 moles of water. Now, you might be thinking to yourself, what does this have to do with what we've been doing in class, right? We've been going from moles to grams, grams to moles, moles to molecules or atoms or whatever. And the answer to that is, well, we're about to use some of that other stuff that we've been using. Namely, on this next problem, we're going to go from moles of oxygen to grams of water. So it is going to involve another step. So we start with, as we always do, our starting number, so 0.550 moles of O2, right? Put that over 1. We're trying to get rid of moles of O2, and we're trying to get to grams of water. Now, if we were trying to get to moles of oxygen, we would just get out, I'm sorry, if we were trying to get to grams of oxygen, we would just get out a periodic table, right? And we would look up the molar mass of oxygen. But that's not what it's asking us for. It's asking us for grams of water, okay? So this is a little different. And I could try to put grams of water on top. And I'm going to write that, but you don't need to write it, because what I'm going to find out is I can't really fill a number in here. There's no point in doing that, because I don't know how many grams of water are in 1 mole of oxygen. It doesn't make any sense for that to be a relationship that even exists, because they're 2 different substances. But what I could do is go from moles of oxygen, similar to the 2 problems above, to moles of water using the balanced equation, right? Which it looks like we have 2 moles of water for every 1 mole of oxygen. And if we cancel moles of oxygen, we are now at moles of water. And the question is asking me for grams of water. So now I can go from moles of water to grams of water. And that is a step you are familiar with, right? Whenever we have moles and grams, we simply go to the periodic table and we add up hydrogen times 2 plus oxygen, and that gives us 18.02 grams. For this one, actually I have to probably get out the calculator for, so 0.55 times 2 times 18.02. And that gives me 19.8 grams of water. Okay. All right, let's try another one. According to the reaction below, how many moles of dinitrogen pentoxide, so that's this stuff, would be produced if you use 7 moles of oxygen with excess nitrogen? So we're going to try to go to from 7 moles of O2 and we're going to take that simply to moles of N2O5. Okay, so go ahead and pause and see if you can finish up this problem. Okay, hopefully you did. And you know that the next step is to go from moles of oxygen to moles of N2O5. Because we do know the relationship between those 2 things. We have 5 moles of oxygen for every 2 moles of N2O5, right? And that will cancel moles of moles of O2 and leave me with moles of N2O5 for my answer. So 7 times 2 and then divided by 5, and that should give me 2.8 moles of N2O5. Okay. All right, next up we have how many grams of oxygen would be required to produce 0.5 moles of N2O5. So see how far you can get with this one yourself. Go ahead and pause and give it a shot, starting with 0.5 moles of N2O5. Okay, so hopefully you did 0.50 0 moles of N2O5. And you put moles of N2O5 on the bottom. Now you'd like to put grams of oxygen on top. The problem is we can't go from moles of one thing to grams of another. Okay, N2O5 and oxygen are two different substances, but I could go from moles to moles and then to grams of oxygen. And I get this ratio is 5 to 2, so it's just the opposite of the one I just had. I had 2 over 5 a minute ago. Now I have 5 over 2. And then that gets rid of moles of N2O5. And now to get rid of moles of O2, I want to get grams of O2 because that is the question I'm being asked. And for this, hopefully you remember, anytime we have grams, we want to go to the periodic table. And so that's what I do. And I get 2 oxygen, so 16 times 2 gives me 32. So 0.5 times 5 over 2. And then times 32. And so that gives me 40. I'm going to go ahead and say 0.0 just to have 3 sig figs grams of oxygen. Okay. All right, we have one more problem. This one doesn't supply us with a balanced equation. So let's work through this one a little bit together here. C3H6O is being burned. So hopefully you remember that means we're adding oxygen and we're getting CO2 plus H2O. Okay. And then we need to balance. So at least initially I would put a 3 to balance my carbon, a 3 to balance my hydrogen, gives me 6 on each side. And that gives me 6 plus 3 is 9 oxygens. So since I already have an oxygen right here, I only need 8 more, so I multiply oxygen by 4. Okay, so I've got my balanced equation. 225 grams of CO2, and we're trying to take this to moles of acetone, which is this stuff. So grams of CO2 to moles of acetone. What would you have to do first? Okay, so hopefully grams of CO2, you recognize you can't go straight from that to moles of a different substance. But what you could do is go from grams of CO2 to moles of CO2, which we've already done this kind of problem multiple times. 1 mole of CO2, according to the periodic table, weighs about 44.01 grams. And now I want to get rid of moles of CO2 and take that to moles of acetone, C3H6O. And our balanced equation shows us that there should be a 1 in front of moles of acetone and a 3 in front of moles of CO2. Okay, and so all I have to do is take 225 and divide it by, and then I'm going to use parentheses and say 44.01 times 3 inside of parentheses, okay? And I should get 1.70 moles of acetone. All right, there you go. That is using moles in stoichiometry. And so we will do lots more practice, and make sure you come to class with any questions about this video.